Greetings everyone. Today we are going to start heat transfer in this course. So, what is heat transfer? So, as we have seen in our daily lives, that if we put a cold can in the room, then the heat will transfer from the room to the cold can. It make the liquid inside the can as hot if the room is hot room. And if we put our main stuff or water bottle inside the refrigerator, it get cold, because in refrigerator it removes the heat from the bottle, it makes it cold. So in both of these processes, heat is transferred from the system or to the system. So heat is the form of energy that can be transferred from one system to another. And for heat to transfer, very important thing is required: temperature difference. So heat is a form of energy that can be transferred from one system to another as a result of temperature difference. As we can see in above examples also, heat is transferred from the cold can to the cold can to the cold can from the hot room, because there is temperature difference. Similarly, from the hot water bottle, if we keep in the refrigerant which is used in the refrigerator will take away the heat from the water bottle and makes it cold. As we all know from the next as we all know from the thermodynamics, that energy can be classified into mainly broadly into two parts: path dependent, path independent. Energy can be classified mainly into two parts: work and heat. So heat is the form of energy that is transferred from the one system to another because of the temperature difference. And whatever the energy transferred from the system or to the system by other means, that is work. Okay. And the science which is concerned with the rate of such energy transfer, which energy transfer? Heat. Such energy transfer, that science is called heat transfer. So now the question is, we can find the how much amount of energy is transferred from the system or to the system by thermodynamic analysis. Why? To study heat transfer. Why? To study heat transfer. Because there are certain points from thermodynamics we can only calculate how much amount of energy. Only the main thing is only amount of energy we can calculate by the first principle, like first law of thermodynamics. But if we want to find the at what amount of that energy, at what rate that amount of energy is transferred, then we need heat transfer. So thermodynamics don't tell about how much time and what rate the energy is transferred from the system or to the system. So for that reason, heat transfer is required. So thermodynamics tell us that if a system go from one state to another state, what is the amount of heat transfer or energy transfer, let's say, to a system. But how long? It takes for the system to undergo from one state to another? Did it answer? No. So that is answered by heat transfer. Like simply, if we take one example, that if this is a container and if it is insulated, say, in starting, and it contains water at 70 degrees Celsius, and this is a rigid container. So if we remove the insulation of this, and let's say we are putting thermometer here in starting, and the thermometer was there. So if we remove the insulation, removed, so energy will be transferred, and let's say it is kept in the room which is at 30 degrees Celsius. So let's say this water temperature has come down to 60 degree Celsius. So what amount of heat is transferred from the water to the surrounding, we want to find. So we can use first law of thermodynamics, means dq minus dw is equal to du. This cross on the d is because q and w are path functions, and this is point function. U is the internal energy of the system. So as this is a rigid container, the work done will be 0, and there is no shaft work. So rigid container PDV work, all works are 0. So amount of heat transfer will be equal to change of the internal energy of the system. Let's say we know the mass and the specific heat of the water inside the container, and final temperature minus initial temperature. So So we can find what amount of heat transfer, but we are not get the answer from the first law, that how much time it takes for this water to come from 70 degrees Celsius to 60 degrees Celsius. So that answer will be given by the heat transfer analysis. So this was the first reason why we have to study the heat transfer. Second, when we go further in this course, we will understand how to calculate the size of heat exchanger and all. So size of the equipment is not decided by heat transfer, by thermodynamics. That is decided by thermodynamics alone. That is decided by heat transfer and conservation of energy principles, not decided by thermodynamics alone. So as we are constantly focusing that thermodynamics tells about the amount of heat transfer, the amount of energy transfer, and heat transfer tells us about the rate at which energy is transferred. Further, thermodynamics deals with equilibrium of states, while heat transfer not. Deals with non-equilibrium of states. So these are the reasons why we need to study the heat transfer.